What would you see if you looked at the sky right now? Of course, the landscape will differ depending on the weather and time of day, but it will still look like most days. Sky, clouds, sun or moon with stars, all of this is familiar and understandable to every inhabitant of the planet. But if we left the borders of our native planet and found ourselves somewhere else, the sky would immediately change. Yes, the same sun would still be shining, but you may not recognize it. This is pretty hard to believe, so I suggest looking at everything with your own eyes, using scientific evidence, and of course, a little imagination. To begin with, we'll go over a few important concepts. Experience suggests that the closer an object is to a light source, the brighter it's illuminated. This is easy to check, even at home with the help of a floor lamp, and any object around that you can find. The further you move the object away from the lamp, the less intense the light shines upon it. Similar logic applies in space. In other words, the further we move away from our star, the lower the light intensity and the dimmer it appears. In my opinion, this sounds pretty logical, but it's one thing to understand it in theory and quite another to apply it in practice. Let's start from the beginning. Mercury. This is the smallest planet in the solar system and also the closest to the sun. The distance between these two ranges from between 46 million to 70 million kilometers. That's about 29 million to 43 million miles. It takes approximately 87.9 Earth days to make a complete revolution around the sun. So yes, if Mercury celebrated New Year's and Christmas, they would happen quite often. The surface of this planet is similar to the surface of our moon and consists of plains and craters. In addition, Mercury is too small and hot to have any significant atmosphere. Seriously, the surface temperature here ranges from -173 to 427 Celsius. That's -279 to 801 Fahrenheit. And since Mercury is the planet closest to the sun, from here the sun looks about 2.5 times larger than it does from the surface of the Earth. And no, clouds don't interfere with the nice view. Let's move on. Most of the surface of Venus was formed by volcanic activity. Venus has several tens of times more volcanoes than the Earth. Its surface is 90% composed of solidified basalt lava. And Venus has a dense atmosphere, consisting of more than 96% carbon dioxide. And all of this, of course, affects the local environment. Despite the fact that the average distance from the planet to the sun is 108 million kilometers, or about 67 million miles, it feels much hotter than on Mercury. Here, it's 462 degrees Celsius. That's 863 Fahrenheit. The sky is orange, like Fanta. And because of its special rotation, the sun rises in the west and sets in the east. Its large number of clouds makes the day on Venus look like an endless twilight. So it's unlikely someone would be able to enjoy the view of the sun from here. Earth revolves around the sun at an average distance of about 150 million kilometers, or 93 million miles. Because of the atmosphere, the sky here is blue, which you of course are aware of, and the moon makes it possible to observe a solar eclipse. Home sweet home. However, it's unlikely that I'll show you anything that you don't already know if we spend much more time on our home planet. So let's move on. Our next stop is a place that never fails to impress. The red planet, Mars, is located at a distance of approximately 230 million kilometers, or 143 million miles from the sun. But this figure may vary slightly. Well, insignificantly by the scale of the universe, of course. But for a person, these are gigantic numbers. Compared to Earth, the atmosphere of Mars is sparse and consists mainly of carbon dioxide. In addition, it's quite cold here. No wonder, the red planet is too far from the sun to properly warm up, and it's periodic dust storms, and you have the perfect Martian landscape. Unlike our understanding of other planets, humanity has a lot of real evidence of what Mars looks like. Photos of Martian sunsets and sunrises show that here the sun appears only 2/3 the size of what we're accustomed to on Earth. And don't think that Mars is actually blue and that all of these stories about it being the red planet are just big words. It truly has that exact rusty shade that everyone is so familiar with. Remember that footage from the film The Martian? That's very close to reality. But the sunset and dawn rays slightly change the surrounding palette. Yes, just as it happens on Earth, but in a different gamut. The atmosphere of Mars has its own filters. Now, we'll take a slight detour. Since Jupiter is a gas giant, we won't try to land on its surface. Instead, I propose checking out what the sun looks like from nearby Europa, Jupiter's moon. It mainly consists of silicate rocks covered with ice and has almost no craters. Because of this, Europa is often called one of the smoothest objects in the solar system. This particular moon of Jupiter is located at a distance of approximately 778 million kilometers or 483 million miles from the sun. So it takes a bit of effort to see it. Firstly, because at such a great distance, the sun looks about 1/5 the size of our full moon. And, well, secondly, the gas giant Jupiter sometimes completely blocks the sun. Now, let's try hovering in the sky above Saturn. It won't be easy due to the strong winds, but let's use our imagination. On average, Saturn is located at a distance of 1,400,000,000 kilometers. That's about 800 million miles from the sun, which is 9.5 times larger than the distance between the sun and the Earth. It's not surprising that it's quite cool here. The temperature in the upper layers fluctuates from -113 to -173 Celsius. That's -172 to -280 Fahrenheit. At this distance, sunlight is at least 90 times dimmer than what we're used to. Nonetheless, the clouds of ammonia ice and the giant rings of Saturn would make this spectacle fantastically beautiful. Although it would feel quite dark for us inhabitants of the Earth. Our next stop is no less exotic. The solar system never ceases to impress. Get this, the ice giant Uranus makes a revolution around the sun once every 84 years, and so is generally in no hurry. After all, is it really necessary to rush when you're so huge? While the planet itself slowly floats through space, wind speeds on it can reach 900 kilometers or 560 miles per hour. So it's better to move to Uranus' moon, Ariel. The distance from Ariel to the sun is almost 3 billion kilometers. That's 1.8 billion miles. That is, instead of a flaming ball, from here you would only see a point of light. While it would be a rather large point, the sunlight here is still several hundred times weaker than on Earth. Scientists believe that Ariel is approximately half composed of water ice and half composed of dense rocks. The average temperature here is about -213 Celsius. That's -351 Fahrenheit. And as there's no atmosphere, the sun would appear to be slightly white. Now, we've reached the last planet of our solar system. Neptune is the furthest from the sun, with 4.5 billion kilometers, or 2.8 billion miles of outer space between the two. However, I'm more interested not in Neptune itself, but in its companion Triton. Scientists suspect that Triton has a stone metal core, an ice mantle with a crust of water ice, and a layer of nitrogen ice on its surface. There are also cryovolcanoes that spew nitrogen. Now, the atmosphere on Triton is also nitrogen and very weak. However, it's possible that light winds are present within it. If you looked at the sun from the surface of Triton, it would appear 30 times smaller than the Earth, and the sunlight would be about 900 times dimmer. Like many other distant objects of the solar system, scientists don't yet know a lot about Triton. Over the past decades, NASA scientists have repeatedly proposed new concepts for missions that would study Neptune and its moons, but they've all come down to a lack of funding. Perhaps, in a few years, humanity will get real pictures of the most distant planet of the solar system. But for now, we'll use our imagination. If you like this video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't already done so. And click on the bell to receive notifications of new, interesting videos that are waiting for you ahead. Until next time.